Hi everyone, welcome to the second part of our outline exploratory data analysis. So let's see the tools and techniques for exploratory data analysis. There are several EDA techniques and tools available in R, which enable data scientists to explore and analyze datasets effectively. EDA techniques that we will study today include summary function, which is used to see statistical summary. And then we will see the density plots and learn how to make histograms to visualize the distribution of data in our data set. So let's get started. First of all, we have the summary function. In R, a summary function is used to obtain a summary of descriptive statistics for a given dataset or a specific variable within the dataset. This function is usually applied to a data frame or a vector, and it calculates the summary statistics such as minimum, maximum values, quartiles, mean, median, and standard deviation as well. So you might be wondering about the importance of this function. The summary function is very useful in data analysis and exploration. It provides a quick overview of the data and helps to identify outliers, missing values, and other anomalies that may require further investigation. It can also be used to compare the distribution of variables within a dataset or between different datasets. Now let's move to our studio to see how this function works for EDA. Well, first of all, I will load my dataset and store it in a variable with the name of cars. Here I will use the function of read.csv, and then I will say cars.csv. Now let's run it. You can see that the dataset has been loaded. At first I will say head cars. All right, you can see these columns with rows. Now I'm going to use the summary function on this dataset. I will say summary, and here I will pass the name of the dataset. Great. You can see the summary of each of the column. You can see that the make and model have the character data type, and the column of year has the minimum value of 1990, and the maximum value is 2017. So it means that the data in the dataset is collected from 1990 to 2017. And you can see that the mean value is 2010. So it means that for most of the cars, on average, the data was collected in 2010. And here is the first quartile, and here is the third quartile. And similarly, we have other numerical columns as well. If we talk about the engine cylinders, then we can see that the minimum value is 0, which means that we may also have cars that does not have any cylinders, and these cars may be electrical cars. And you can see here is the first quartile, the median is 6, and the mean value is 5.6, and the maximum is 16. So it means that we also have big cars that are using 16 cylinders. And that is how you can also inspect and do exploratory data analysis on other columns as well by using the summary function. So let's move back to slides. Next, we have density plot. Density plots in R are a type of data visualization that display the probability density function of a given variable. They're useful for visualizing the shape and distribution of a dataset, and they are often used in exploratory data analysis. So, how to create a density plot? To create a density plot in R, you can either use the plot density function, which is the built-in function, Or you can also use the geom density function, which calculates the kernel density estimate of the data. The syntax is here, as you can see. Just use the ggplot function, then pass the data frame, and then the aesthetic, and here the geom density. Now let's move to our studio to see how it works. Well, first of all, I will create a density plot using the simple density function. So I will say plot, and inside the plot function, I will use the function of density, and here I will pass my dataset name, and I will say that create a density plot for year. And here I will pass a parameter with the name of main that represents the title, density plot of year. Let's run it. Now you can see a beautiful density plot here. The year of 2014 to 2017 has the highest density of 0.15. And you can see that for the rest of the years, the density is below 0.05. Now, how about making the density plot for the rest of numerical columns? So before doing that, I will first have to remove the null or the missing values if there is any inside my dataset. So in order to do that, I will use the function of na.omit, and here I will pass the dataset name. Great. So let's do this work by using a for loop. I will say for column in column names, and inside that I will pass the name of the dataset. All right. And here let's make an if condition that make a density plot if and only if the column is numeric. All right. Now inside this for loop, I will just simply create or plot a density plot using the plot and then density function. And here I will say take the cars data set and make a density plot for the column in the iteration. And here I say main equals to, and I use the paste function because I'm going to concatenate a string. I will say density plot of, and whatever the column is in the iteration. So now let's just run it. Great. So you can see the last column here and the density plot of MSRP that represents the price. And next we have the density plot of popularity. You can see that the popularity between 0 to 1000 has the highest density. And the city MPG is between 15 to 30 that contains the highest density. And you can see the highway MPG as well, that is between 10 to 50 with a density of 0.6. And this is the density of the number of doors that is the highest in 4. And you can see the density in engine cylinders that is highest in 4, 6, and 8. And here's the density for engine horsepower and so on. Now let's make a density plot using the ggplot library. So first of all, I will load the package of ggplot2. All right. And here I will say ggplot function. And first of all, I will pass the data frame. And after that, I will say aesthetic and take the variable of, let's say, year. and say geom density, and I use the keyword of fill equals to light blue, and let's just store this function in density plot 1, and here I will say den plot 1. All right. Now you can see a pretty visualization with the help of ggplot2 package. The density is the highest after 2010, and you can see the density for the rest of the years. So that is how you can make a density plot in R. Now let's move back to slides. Next we have histogram. So what is a histogram? In R, a histogram is a type of plot that shows the distribution of a variable by dividing the range of values into a set of intervals or bins and counting the number of observations that fall into each bin. Histograms are often used to visualize the shape of data distribution and to identify outliers, skewness, and other distributional characteristics. Now, how to create it? To create histogram in R, you can use the hist function, or you can also use the geom histogram function that is provided by the ggplot2 package, which calculates the frequency of each bin and plot the result as a bar chart. Now let's move to RStudio to see how this one works. All right. So let's make a histogram for the column of year. So that is quite simple. If you want to make a simple histogram, then just use the hist function. All right. So first I'll say hist, and here I will pass my data set, and I will say take the column of year. That will create a simple histogram, as you can see. The distribution is the highest for the year of 2015, and you can also see the distribution for other columns as well. And the frequency is more than 3000 for this year. Let's make it a little bit more beautiful. I will say hist, take the cars data frame, variable of year, and color equals to, I will pass the color here, which is cornflower blue, and here I will pass the name. I'll say histogram of year, and I pass the xlib, which stands for x-axis title. I say year, and the y-lib, which stands for y-axis title. It should be frequency. All right. Now you can see that the presentation of your histogram looks much better. You can also make the histogram by putting it into the above for loop, and you can make the histogram of all of the rest of the columns. So let's do it. I'll say for column in call names, I pass the cars dataset, and inside the for loop, I say if is dot numeric, and take the cars dataset, take the column, and inside this for loop, I just simply use the hist function, and I say take the cars dataset, and whatever column is in the iteration, and here I pass the main, and I use the base function. I say histogram of, and whatever is the name of column. All right. See, you can see the histogram of price, histogram of popularity, histogram of city MPG, highway MPG, and number of those, engine cylinders, and engine horsepower as well. So now let's try to do the exploratory data analysis by making the histogram through the ggplot2 package. For that purpose, I will use the geom histogram function. Let's create a variable at first. I will say histplot1, and here I use the ggplot function, and I say take the data equals to cars dataset, and the static equals to x equals to, and for instance, we take the variable of engine horsepower, and here I say geom histogram, and I use the parameter of fill equals to light blue, and I say color equals to white, and after that I say labs that represents labels, and inside the label I say x equals to, x title should be engine horsepower, and y title should be frequency, and the title should be histogram of year. So that is how you can customize your histogram. And let's use one more thing. I use theme black and white, and now let's just plot. All right, let's just run it. But before running, I'll place the concatenation on the above lines. All right. Now you can see a pretty histogram here. This is the title, x-axis, y-axis title, and this is the distribution for each of the engine horsepower in your dataset. And you can see that the distribution is highest at this point, and the frequency gets low when the horsepower increases 500. Now let's get back to slides. So this is the end of today's lecture. You have learned how to do exploratory data analysis through summary function, density plot, and histograms. So I have designed the homework for you. Your task is to create a summary of the dataset and then do statistical and descriptive analysis. And here's the link of the dataset. Now good luck, see you next time.